Welcome everyone. So in this lecture we're going to start with chapter 4, which is program control in C. And in this chapter the first topic that we will be covering uh, is counter controlled iterations and how they are related with the for loop, and we'll cover the do while loop and look at switch statement, which can be used to do something similar to if else statements. Then we look at break, continue, uh, and some more topics. So let's get started. So the first topic in this chapter that we're going to discuss is uh, a brief categorization of loops and how we can classify them. Now, when we're talking about loops or statements that allow us to repeat some part of our program multiple times, also known as loops, then we basically have two categories. The first one is one that is based on counter controlled iteration, and then the second category is based on what is called the sentinel controlled iteration. Now the first category, the counter controlled iteration, is also called the definite iteration. And so what do we mean by definite iteration? Well, counter controlled iterations are generally employed when we know exactly how many number of repeats we will be doing in our program or in our loop. So when we know at the start of our program exactly how many repetitions we will have to do, then we generally employ loops which are based on the counter controlled or the definite iteration method. Now, a lot of the times we are in situations when we do not know at the start of our program exactly how many repetitions we will have to do. Then we basically employ what is called a sentinel controlled iteration, or the iterations which are based on sentinel variables or sentinel values. And of course these are called indefinite iterations because we do not know ahead of time, or we cannot predict exactly how many repeat cycles we will have to do. Now, in counter controlled iteration, a central part of your looping is basically what is known as the control variable. And the control variable is generally used to count the number of iterations or the number of cycles that your loop has gone through. And in every cycle, this control variable is generally its value is either incremented or increased, but it can also be decreased as well. But most of the examples that we have seen, we generally are increasing the value by just one. Now, sentinel values are values which we discussed a couple of lectures back. Um, and these are generally known when we do not know exactly how many repeats or how many cycles we will have to do. Now, this would be in cases where our program terminates based on a certain input that a user gives us, or it could also be a value that comes up during the program. So we cannot predict it ahead of time, but sentinel values generally is used to indicate that, okay, when do you stop, or when does your loop stop the repetitions or repeat cycles. Now, if you're looking at counter control, you generally have to first give a name to your control variable. You then have to give it an initial value. So that's the value which your loop starts with. And then you obviously have to specify an increment or a decrement. So by how many values do you want the value of your control variable to jump in each iteration, and then of course your condition or your loop basically terminates when you reach the final value of your counter variable or your control variable. One example of a counter variable is given on this slide. So you could initialize it as an unsigned integer data type whose value or first value or initial value is 1. Let's look at a very simple example, which is basically a while loop. In this while loop, you have an unsigned int counter initialized to 1. So that's the first step. Initialization is the first thing that you need. Then when you get to your while statement, now in this loop, you have to specify the iteration condition. So that's the condition that one, it is false, your loop will stop. And then of course the final thing that you need to specify is the increment value. Notice that you're using the increment operator plus plus to increase the value of your control or counter variable. Okay, now if we run this program, what it should do is it should just print the value of the control variable or the counter variable. So we could have initialized this using two statements. So instead of writing just counter is equal to 1, we could have also written it this way, but it doesn't really matter too much. So what will this loop do? Well, it will start off with 1 and then it will stop when the value of the counter variable reaches 11. So what it does, it prints 1, that's the first value, initial value of your counter variable, then it increments it, prints 2, 3, 4, 5, 6, 7, 8, 9, and then when it gets to 10, when counter increments to 11, you come back here, and then that's when your loop stops. Now this was an example of a counter controlled iteration because you knew how many iterations or how many repetitions you wanted to do, which in this case was 10. One more thing that you could have done is that you could have put your increment statement and inside your while statement. In fact, you could have put it inside the conditional or the condition part of your while statement. Now, what does this do? It first increments your counter value because this is pre-increment, and then it checks whether the value of counter is actually less than or equal to 10. If it is, it just prints the value of counter. So instead of writing counter down here, you can write it like this. You can put it inside the while statement, and that will save you one line of code. Now, in general, when you are in a situation where you have to do counter controlled iterations, or rather when you are in situations when you know exactly how many cycles your loop needs to run for, in those cases you generally do not use the while loop. in fact, it is far more easier to use another type of loop, which is called the for loop. So for loop is generally suitable for counter controlled iteration. So when you know exactly how many iterations you will have to do, then it's generally preferred to use the while loop, and the reason for this will become clear shortly. So let's look at a statement that uses the while loop, the for loop. So what do we do? Again, we have a counter variable. So we write the for statement. We have a counter variable which we initialize to 1. It is an unsigned int. Then we have a control statement which follows after the semicolon. Then you have another semicolon, and then you have the increment statement, and then you basically just print the value of the counter. So what is the for loop doing? You starting with a counter value of 1, you're checking if this value is less than equal to 10. If it is, you go down and you print your value of your counter variable, and then you come back and you increment or increase the size or the value of your counter variable by 1, and you repeat the process. Okay, now why is while loop preferred for these cases? Well, let's just simply compare it with our original. So why is the for loop preferred, over the while loop for counter control situations? Well, you can see, right, over here you had to write 3 statements when executing the while loop, whereas with the for loop you just have to write one single line, and it takes care of everything. So it makes things much more simple for you to do when you are in situations where you know exactly how many cycles you will need to loop around. Okay, so in this case you know exactly you have to do 10 cycles, so that's why it is much more simpler to use the for loop than the while loop. Okay, so let's look at the while statement in a bit more detail. So one of the advantages of this, of course, is that it does it all. So it basically, you have a single statement which basically takes care of everything. Now, what is the disadvantage with the for loop? If you're in a situation where you have sentinel values, if you do not know exactly how many cycles you will have to do, then it becomes a bit more tricky to use the for loop. In that situation, it would be better if you used the while loop. So if you are looking at sentinel values or sentinel controlled iterations, then it would be preferable to use the while loop instead of the for loop. Okay, so so if we're looking at that previous program, yes, we had our counter, it was initialized to 1, then we had a loop continuation condition. So the condition was, we checked that the counter was less than equal to 2. If it was, we printed the value of the counter, right? We print the value of the counter, and then we increase the value of the counter by 1 after we have printed it. Now let's look at this statement again. You have the for keyword followed by parentheses, and then you basically have the initialization part where you basically take your loop control variable and you initialize it. Then you have a semicolon, then you basically have your loop control condition. So this is the condition which will be checked in every iteration to see if it's true or false. Then you have another semicolon, and then you have the iteration part. or the increment part of the loop. So there are basically three parts. All three can be put inside the for statement. It's a single line, and then remember that you have to put a semicolon in between. So you need to put a semicolon here and a semicolon here. Okay. Now, one of the things that you need to remember, and that happens very frequently when you are writing loop statements, is called a off by one error. If you had written less than 10 in your condition instead of less than or equal to 10, then your loop would have executed 9 times instead of 10 times. So it would have executed one time less than what you had wanted it to do. So remember that this is something that can happen. So you need to be careful about how you write these statements, because this is a very common error. Okay, so what is the general format of a for statement? Well, again, let's repeat this. You have a for statement, then you have the initialization part, then you have a semicolon, then you have the condition which will be used to terminate your loop, and you have another semicolon, and then you have an increment statement. You could also have a decrement statement if you want to go in the other direction. So and then you obviously will have the body of your for statement, which will be its start and end will be reflected by curly braces. If you have only one statement in your for loop, then you do not have to put the curly braces, but it really is up to you what you want to do. Okay. Now, one more thing that the for statement allows you to do is called comma separated list of expressions. Now, in the initialization part and the increment part, you can write down multiple statements. It's just that you have to separate them using commas. So let's say that in the initialization part, if you want to initialize two variables, then you will have to separate them using a comma. And similarly in the increment part as well, you can increment multiple variables by separating their increment expressions using the comma operator. Another thing that you want to remember is that the evaluation of these expressions will be from left to right. So the expression that appears on the left will be evaluated first. So let's look at a couple of examples of these. You may want to use these in situations where you want to control your loop using two variables. If your loop can terminate based on the values of two variables, then you can use comma separated statements in your control part of your loop. Right. Another thing that you should note is that the expressions in the for statement are optional. So all three expressions, which means the initialization, the condition, and the increment statements are optional. So you do not have to write them. So let's say if the condition expression, which is in the center, is not present or is not written down, C assumes that the condition is true, and so it will create what is called an infinite loop. So if you omit that statement, it will just keep running forever. Generally do not do that, but there are some times where you might want to do it. If you omit or do not write the initialization statement, so let's say you write a loop where the initialization does not contain anything, and then you are writing it based on some variable x less than 10 x plus plus, then what the loop assumes is that the initialization is done somewhere else in the program. So it will assume that you initialize the variable x somewhere before you wrote down the statement of the for loop. Similarly, the increment may also be emitted, and if it is emitted, it will assume, so if you remove this final statement, it will assume that it is being evaluated or the increment is being done somewhere within the body of the loop. So again, this is not something which is too important, but just know that it exists. As far as the increment expression is concerned, if you write them the way that I have written them in the for loop, in the statement of the for loop, so over here, so if you write it here, then it doesn't matter how you write it. You could write it like this: counter is equal to counter plus 1. You could also write it like counter is plus equal to 1, or with a post increment, with a pre increment and a post increment. All of these will have the same effect, okay, because they're all inside the statement of the for, so they will all have the same impact. Okay, so just remember that. As far as the initialization is concerned, you are allowed to initialize using some sort of arithmetic expressions like this. So you can write the counter control variable to be j is equal to x. You are not required to write something like j is equal to 1 or j is equal to 0. You don't have to. I mean, you can write it as something like j is equal to x. This is perfectly fine. You're allowed to do it. And again, similarly for the condition as well, you don't have to write it in terms of exact variables. You can write, you don't have to write a definite value. You can write it like this. So j is less than equal to 4 times xy. Similarly for the increment as well. In fact, if you check these values for x equal to 2 and y equal to 10, this is what your loop will actually feel like. This is what the impact will be. So this is something that you're allowed to do. Now let's look at the flow chart of the for loop. So if we have counter is 1 and conditional value or the termination condition is counter greater than 10, and then the increment is just 1, our loop will initialize counter to 1. It will check if counter is less than equal to less than equal to 10. If that's the case, it will print counter. It will then increment counter, and it will come back to the condition, check the condition. If it's true, repeat, and then once the condition is false, which will be when the loop has repeated 10 times, so at iteration number 11, counter will be 11, it will be false, and then your loop will terminate, and you will go to the next statement that comes after the body of the for loop. Now there are a few examples that I would like to go through that just show you how the for loop can be used. First example is I is equal to 1, I is less than equal to 100 plus I. So what that will mean is your first value of I is going to be 1, second value of I is going to be 2, then you have 3, and you will keep going until you get to 100, and then once I becomes 101, your loop is going to stop. You don't always have to increment, you can decrement as well using the decrement operator minus minus. So in this case you start off with a value of 100, so this is your initialization value, then you decrease it by 1, so your next value is 99 and 98 up till you get to 1, and then once you get to 1 your value will decrease to 0, and that is when you will stop. Similarly, this is another example. Your initial value in this case is 7, so the first value is 7, then your increment is also 7, so your next value is going to be 14, then you will get to 21, then 28, and then keep going until you get to 77, and that's when you will stop. Similarly, for the next one, you start with I, you check if it's greater than I is equal to 20, you check if it's less greater than equal to 2, which it is, you decrement not by 1 but by 2, so first value is 20, 18, you keep going until the final value of 2 is printed. And then similarly you can check the values for this loop, which are 2, 5, 8, 11, 14 and 17, and then also for this one you can verify that these are the values that will be printed. Let's do another slightly more detailed example where what we want to do is we want to sum all the even integers from 2 to 100. Okay, so we can do this using a sum variable which we can initialize to 0, and then we can add the values of our loop variable, let's call this I, inside this sum. So keep adding this, but I, first of all, the first value of I needs to be 2, and then the second even integer is 4, and the third one is 6. So the loop kind of needs to go through these values 2, 4, 6, 8 until it gets to 100, and then it needs to keep adding these values or accumulating them inside the sum variable. So how can we do that? Sum is initialized to 0, and the for loop is unsigned int number whose first value is 2, condition is less than equal to 100, so it terminates once you get to a value which is larger than 100, and then of course the increment that you do is 2, so the number is increased by 2, and then in every time you execute the loop or you go inside the body of the loop, you accumulate these values, and then finally you print the sum, which in this case is 2550. Okay, now let's do a bit more complicated and a little more interesting example, which is maybe practically more useful. So a person invests $1,000 in a saving account with an interest rate of 5% per year. So what we are interested in knowing is how much amount will he have in each of the 10 years that he has invested in this account. Now this is generally evaluated using the formula of the compound interest, which is written over here. So what is P? P is the original investment or the principal. R is the annual interest, so that is 5%. N is the number of years for which the money has been invested, and then A is the amount on deposit at the end of year number N. Now this problem obviously involves a for loop that needs to run 10 times. So let's look at the solution. So we have the principal amount, which is 1000. Our rate is 5%, so 5% basically translates into 5 divided by 100, which is 0.05. Then we have printf statement, which prints year and then the amount on the deposit. Then we basically go into our loop where we are looping through the number of years. So we start with year 1, we keep checking until we get to year 11. We increment our year after this statement is executed. And what is this statement? This statement is our amount, which basically is just the formula. So this is A, principal is P, so A is equal to P, star is just multiplied by, and then this seems interesting. This is something we haven't seen before. Talk about it in a second. But what is this? We have rate, which was R, and then year, which was N. Now what do we mean by this particular thing here? Well, we are calling a function POW, which basically is power. And what is the power? This basically, if you call this function or use this function x comma y, what mathematically this means is x raised to the power of y, right? So what we have here is POW, so power 1 plus rate, which is R, comma year, which was N in our mathematical notation at least. So what this means is we are raising 1 plus R to the power of N. Okay, so we're just implementing our formula. One more thing that is highlighted on this slide, we are using this preprocessor directive include math.h. So what we mean by math.h is that we are basically calling the math header file. Now the math header file basically contains a lot of functions that are used for mathematical operations or mathematical calculations. This power function or exponential is basically also a member of math.h. So we need to ensure that this is included, otherwise our program will not recognize this function. Okay, and so then we go ahead and we print the year and then we print the amount using a printf statement. So let's look at the output. There are a few more things in this program that I want to cover. So what do you see? So you see year 1, and then you see the amount of deposit, which is 1050. So the amount on deposit after 1 year is going to be 1050, then after 2 years it's going to be this, and after 3 years it's going to be this, and at the end of 10 years, if you invest $1,000 with the annual 5% interest rate, you're going to have about $1,629. Couple of other things which are important on this slide that I would just quickly like to mention. Number one is, notice that you are writing this as 04, so this is percentage 4s, percentage 21s, and then you write this first string which is year, and then the second string which is amount on deposit. Now what does this do? Well, percentage 4s basically means that you have a string, and that string is going to be printed using 4 characters. You have a string which is 4 characters long, so 1 2 3 4, so your year basically appears like this. Then the second string is percentage 21s. So what that means is you have a string of 21 characters, 1 2 until you get to 21, and so this is a string which actually has 17 characters, so it will be write justified. So if you have this field which consists of 21 characters, it will be write justified, so it will appear on the right side. If it was left justified, then it would appear on the left side, and you will have some blank spaces. In fact, you will have about 4 blank spaces, because this string you can actually count has 17 characters, and you are putting it in a string of 21 characters, so you will have some blank spaces, and you can actually see that you have about 4 blank spaces here in between the two. So this makes your text appear a little bit nicer and better to look at. Similarly for the other part as well, when you're looking at floats, you are writing something like 21.2f. Let's just quickly go back here. So you have 21.2f. So what that means is this amount is going to appear in this field. So you have 21 characters, and then you are going to get write justified amount, and that amount is going to appear with 2 decimal point precision. So it will be like maybe 1050.54 or something. So the 21 basically specifies how much space you're allocating for these, and then the 0.2 basically specifies how many decimal points accuracy you're going to have. Do remember, and I've told you this in previous lectures, that when you actually use 0.2f, it does take care of the rounding off. So if you have a number like this where you have 0.907, now this last digit is greater than or equal to 5, so that means this digit is going to be rounded up to 1. Similarly, if you have something like this where the last digit is 4 and you use 0.2f, then this will be 14.23, so it will remain the same. Similarly for this, it will also appear as 18.67. Now because of this rounding off, because you may have some extra digits here that are there but you're not printing them, it is possible that you may end up in situations where your answer is not exactly what you expect. So if you just add these, your answer actually is 13.90, but what you end up seeing is 13.91, and that is because maybe the answer that you got was 13.908 or something. So this, even though you don't see it here, it's not being printed, it still has an impact. So just remember, you have been warned. So remember this is something which is which you should probably know.